Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to have a look at incompatible features. We looked at compatible features in a file system in a previous video, and now we want to look at incompatible features. So these are features that if your file system contains these features, but your operating system doesn't support these, you should not mount the file system, not even as read-only. And definitely, if you shouldn't mount it, you shouldn't be running the file system check utility against it either. Again, why do we care about these features? Well, definitely we care if we can't mount the file system, but we also care because it does affect things like metadata and also how the data is structured. What is the set of incompatible features that we might run into? Well, the first feature is compression. So you might have a compressed file system. The second is the file type feature. And what this is, if you have this, your directory entries include the file type in the directory entry. And we'll discuss this in a little bit more detail in the future. But essentially what it means is that one of the bytes that was normally used for something else is instead used to indicate a file type. Recover. This feature tells you that your file system needs recovery. Journal dev. This tells you your journal is stored on an external device. So instead of being stored in some of the blocks on your file system, the journal is stored externally. This might be done for various reasons, mostly performance. It's not terribly common, but it's something you might run into. Meta block groups. So this tells you that meta block groups are in use. We'll talk more about that later. Extents. The file system uses extents. Now, extents are used in order to better store large files. If you look at the default way of storing files, you have a lot of metadata entries, and extents allow you to reduce that a lot. 64-bit feature allows you to have 2 to the 64 blocks as opposed to the standard of 2 to the 32 blocks. And this can be handy if you have a larger file system. You don't want to be limited to a mere 256 terabytes. You want a larger file system, or you want blocks that are smaller. So you can enable this feature. Multiple mount protection. There are safeguards to prevent more than one person from mounting a file system at the same time. And if they try, the best case scenario is that one of those mounts will become read-only. There's flexible block groups, and we'll talk more about those in the future. That's another nice feature if you have a larger file system. You can also have extended attributes stored in the inodes. If you have support for large extended attributes, they can be stored in the inodes with this feature enabled. Dir data is another feature, and this feature allows you to put some of your data inside the directory entry, and this is useful if you have small files. The BG meta checksum feature. It's not commonly used, but it allows you to have checksums in the metadata stored inside your file system. Large dir supports directories with greater than 2 gigabytes or 3-level H trees. And there's inline data, where the data is inline in your inode files. at least some of it. And again, this is useful if you have a lot of smaller files. And encryption. If you've encrypted your inodes, obviously, if you don't support it, you're going to have a really hard time mounting that file system. So which of these features affect the layout? The flexible block groups are one, and here's how they work. You take multiple block groups and you treat them as one logical block group. And the bitmaps and the inode tables for the entire logical group is stored in the first block group. So if we had, say, 4 block groups per logical group, then the first one would store all of the bitmaps and the inode tables in that group. And what this does for you is it allows you to have large files that are contiguous on the disk, which improves performance. Meta block groups. Here you have the file system partitioned into several meta block groups. What happens here is that the group descriptors for the meta group, not the entire file system, is stored in the first, second, and last block group of that meta group. So this does a couple of things for you. It makes those group descriptor tables smaller, and it can save you a lot of space because it's only stored in 3 of the block groups instead of all of them. Also 64-bit mode. Indirectly, this can affect your layout because it changes the size of some of the structures, such as the inodes, etc. And we'll talk more about that in some future videos. So again, how do you get this information from your file system image? I showed you in a previous video how you could use the fstat tool, and here was the format. It was just fstat. You would possibly have to give it an offset if you had an image that contained more than just one partition, which is what I recommend you always capture. Get the whole thing if you can. And then the path to your image. And when you ran that, it gave you a whole bunch of information. And so then I piped that out to a file. So let's have a look here at the file that I captured. And if we look at the beginning, we will notice that for incompatible features, it had file type, extents, and flexible block groups. So we have flexible block groups, which tells us that it's going to change the layout of our different groups. So here we see I have a super block, group descriptor table, super block, group descriptor table, no super block or group descriptor table, super block, group descriptors, again, etc. So there's multiple flags actually and features on this one that determine exactly how this works. But we are using flexible block groups here. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend.